my courses will be more focused on the things that you cannot study by the textbook.
That's the old version. Will be old version.
Okay.
Yeah, but in the old version.
And Angela will give you a head start for how to connect it, but after I finish the introduction. And I really appreciate them to spend extra time for setting up the equipment. Okay, but they are not mandatory obligated to because they are also course taking students. So I really appreciate them. So basically that's the sensor that we have. Okay, and we have some special sensor, other special sensor, but we cannot move in the whole lab here. I mean, this is already. I'm very surprised they already moved that this many already. Okay, that's thank you. And so the first, as I said, the two-ground mobile robot, this one, and the bigger one, and this one. And this two-ground we call TurtleBot 2 and TurtleBot 3. It's more like a research platform. So that means it's an open source. So you can connect it to the motor, you can connect to things, you can add things by yourself. And 这把枪拆掉了，这把枪不是你们拆了，为什么拆了呢？我们将来要 demo 的呀。不是，那是以后啊，上课你现在你还要装回去哦，因为我们还要继续 demo 的。Okay, all right. So originally we have a gun in here. Well, because maybe they are for moving here, you don't really need that gun. Okay, and but I asked them don't disassemble it. Okay, we need to demo that. And there is also gun in the ship. Okay, so I just introduced and what is this? This is ground mobile robot. Okay, until I took the section, I connected. So this is two robot. TurtleBot 2 and TurtleBot 3 you need for the first task. Okay, this is TurtleBot 2 and this is TurtleBot 3. One bigger one, small one. So 3 basically tasks trajectory generation. One is using simulator, 2 using the actual robot. And what is the purpose? Because we are applying kinematics. Yeah, in the simulator, your calculation, for example, in the team, you write a good equation, well, very nice, generate trajectory. But in the actual, is that true? They even add their artificial disturbance, but is that true? Is that a real disturbance? So that's what I said, they did a good job, but I wanted them to see the real data. What I mean by real data? In the real robot. In the real environment, and then you can see this trajectory will have some air. Once you have it, you can observe those air. Well, what is AI doing? Solving uncertainty, and those air you cannot predict it. For example, in their team, they can assume their air disturbance can be Gaussian distributed, but it's just your assumption. Technically, this air uncertainty is stochastic, could from environment, could from sensor, and I don't think it's Gaussian distributed. And nonlinear, stochastic, random, and so the only thing is that's why at this time, if you're using AI to solve this trajectory error, so which I think there is one of the project is the trajectory planning, which is JV that trajectory planning, and another is the trajectory tracking, which is by Matthew, and Matthew is point is, if you are doing the module 3, technically you are fixing this trajectory here. You are controlling the pulse, and you have to fix this here. Well, then you say, oh, Professor, if this air a little bit off, so what? Yeah, depending on your application. Depending on your application. If you are landing on a particular pace, the trajectory is not allowed to offset. Okay? And also certain trajectory. If you have air, it could hit things, and also it will have an unstable flight if you didn't follow a good trajectory. So in this case, I want you to observe those kind of trajectory, and it's ground. It's not that bad. Trajectory air, even for ground, is not really that bad. But your project is doing UAV, then that's really bad. Okay, the trajectory is really bad. And the trajectory air. Okay, so this is the first task, the equipment that you're going to use it, and you will generate a trajectory plot, and so the kinematics attached here. So, second, the first task is doing the drawing of the trajectory. Okay, which is you're calculating the final post. So using the same equipment, the first task is you generate the trajectory. Okay, and simulator, actual robot. Second is you're calculating your final post. When you're calculating your final post, that means you can calculate this trajectory. Every point, you get the post. So you will get an error, right? This is your desire, and this is the other, right? So you will see that error. Third is a UAV, so which first through simulator. Through the simulator, and there's a PD control. Actually, that's currently the Simon J and is your project leader. They are solving these things, and they are quite successful right now. I mean, to do own flight control. Right now, if you operate a UAV, so for example, as the Jacob, the flight control is for the post control. There's a PID, KD or KD. Do you design and implement it by yourself, or you just buy it?
Yep, I buy it.
You just buy it. But we design by ourselves. So in this case, what's the reason? If there's a flight control means position control, pose control, right? If I want this pose, then I can using a KD, KIKD, and trajectory control. So that's in my UAV dynamic, which is control the 4 motors, and you achieve to a position. So PIPD control, the input is the motor. So which this model, I mean, you can read, is implement this UAV model, which is input and output, which is a position control. And so I will explain why I asked Jacob this question. So in this case, if there's available, there's a UAV model here. What I'm talking about is the KD. This is the PD control for the pitch rotation. Okay, for the pitch rotation. So the output is the pulse. Okay, the input is the motor. Okay, is the motor. Is this 4 motors? Okay, so which is the second is this UAV. It doesn't matter. It's the same principle. Okay, 4 motors. Okay, 4 motors. And so you can think that this is like a lever. Okay, the lever. Have you played in the playground? You sit down here. The other person will up, and the other person heavier. Then you will up. Do you know what I'm talking about? That means the code lever. Thomas,
Sorry?
that things is called lever, which like kids they play in.
Oh, yeah, lever board.
Lever board.
Lever. Like that.
So the UAV, the model, you think it is that? Do you know what I'm talking about? 跷跷板. Okay. Lever. So there is a supporting point here, and you can think there's two kids. If the one kid is heavier, so he will going up, and the things will going up down. So motor. So when you rotate, so when the things rotate, you will generate a linear force. So in UAV term, this is called thrust. So it's like force, like when the kids in there, the force mg, right, which is head. So if this one is heavier, if this one is heavier, this one is lighter, what will happen? This one, if larger than that, if this is things, here is bigger, here is smaller, what will happen? 文字。No, come on, 跷跷板。Here is bigger. What will happen? What does that call? You will rotate, right? Come on. The difference of the torque, right? 这个是 force 嘛，这个是 D. So force D1, force 2, D2. If force 2 times D2 equals to F1 equals to D1, 力矩嘛 right? Force times the difference is the torque, right? If they are equal, what will happen? They will not rotate. If there is a torque difference, what will things happen? 扭矩只有不等的时候才会旋转嘛，你跷跷板是转的。So, ask you again, if F1 D1 larger than F2 D2, tell me again, what will happen? Rotate, there is two rotation. Huh? Clockwise or counterclockwise? 逆时针、顺时钟嘛，旋转有两个方向嘛。One is F1 D1 larger than F2 D2. One is this is less. Another is equal, right? Only three possibility. 物理没学过这个力矩和啊 net torque and net force equal to 0. Net torque is equal to 0. The thing is not moving. Net force equal to 0. There will be no linear motion. Net torque is there's no angular motion. So we call that what? Mechanical engineering. When net force, 这个是扭身定律嘛 net force and I saw that there you are mechanical engineering, right? When net force 静力为零，静力矩为零 net force equal to 0. Net momentum as 0. 啊 ？Static equilibrium 平衡点啊 ，equilibrium 你没有学过物理学啊？物理第一章就在讲静态平衡点啊 ，static equilibrium 静力为零，静 torque 为零 ，net torque net force one is linear, one is angular. Well, this one is no matter. So 静力为零，静就是这个东西不会动，对啊。So 就像有人推你嘛，两边的力量推你，如果是一样的，你会动吗？你不会动啊。还有呢，我现在一个人在背后推你，一个人在前面推你，前面推你力量大，你是会直线走还是会转？ 就一个人在前面这样子推，一个人在背后这边推，这个力量大于它。你是转弯嘛，那就是 torque 嘛。So in this case is torque. So in this case, let me ask you again. If this one 不是力矩嘛 ，moment. So if this one times this larger than this one and this, tell me again. Clockwise. This one larger than this, right? 这个力量这样子大，这个力量小，它不是这样子的。Yeah, counterclockwise. So counterclockwise. And if this one less than this one, clockwise. If it's equal, it's not rotation. It's not rotating. So in this case, by controlling and this rotation generates a torque, right? 旋转产生力量 right? It doesn't have to take UAV course. This is physics. Okay, this is the physics. Okay, just go back to review your physics, chapter 1. Okay, it's not quantum physics. Okay, I'm not talking about quantum physics. It's physics 101, Newton's law. Okay, about the moment, torque, force, net moment. Okay, go back to read, and it doesn't have to be nothing to do with UAV. Okay, but UAV using this principle for making rotation. So in this case, if this one and this one is not equal, T1 times D not equal to T3 and T3 times D, so it will rotate around which axis? Yes, this one rotated, right? If this one times this one not equal to this one, they will rotate around which axis? So 所以它是绕着哪一轴旋转 ？Which axis？ 答案就在上面，你这样看不出来，它会绕着哪一轴旋转 ？Y